For this example, this question, we asked to find the equation of a parabola, passes through the point 211, has a vertex at negative 1, 4. Now, need to use turning point form with this. Y is equal to, we don't know what the shape factor is going to be. We'll go x plus 1, which comes from here, squared, and then plus 4, which comes from here. Now, to find out the value of a, we will substitute in the second lot of coordinates that it passes through. So y is equal to 11 when x is equal to 2. So 11 will be equal to a by 3 squared plus 4, or 11 will be equal to 9a plus 4. Take away 4 from both sides. 11 take 4 is 7, that'll be equal to 9a. Then we divide both sides by 9, that'll leave us with a is equal to 7 over 9. So what that will then mean is our equation will be y equals 7 over 9 x plus 1 squared plus 4. Now for this next question, we have the equation y is equal to 3x squared minus 11x plus 10. We want to find the x-intercepts, or the solution for when y is equal to 0. In order to do that, we'll need to factorise it. So I'm going to do one of these little cross multiply things. And factors of 3x squared could be 3x and x. And factors of positive 10, now looking at the equation, because we have a negative 11x in the middle, and the last term is a positive, that would mean that both the factors of 10 would need to be the same sign. So both positive or both negative. With the negative 11x, it tells you that they'll both be negative. So I'm going to try negative 5 and negative 2. Multiply through. 3x times negative 2 is negative 6x, plus negative 5 by x is negative 5x. And those two signs together will be a takeaway, so negative 6x take away 5x is negative 11x, which is what we're after. So that tells us that 3x take away 5 is going to be our first pair. And x take away 2 is going to be our second pair. So that's now factorised, and we want to solve that for y is equal to 0. So what we do is we apply the null factor theorem, where we take each one of those two factors, or each one of those two brackets, and set them equal to 0. So we could have 3x minus 5 is equal to 0. Add 5 to both sides, we have 3x is equal to 5. Divide both sides by 3, we end up with x is equal to 5 over 3. Or, for the second bracket, we say x minus 2 is equal to 0. Add 2 to both sides, x is equal to 2. So the two x-intercepts, or the coordinates for the two x-intercepts, will be at 5 over 3, 0, and or 2, 0. And that's the answer to that question. Now for this question we have the equation where we have negative x squared plus 2x plus 8, or 8 plus 2x take x squared, and we're asked to find the maximum value of y. Now this is a negative x squared graph, so that's the shape that it's going to have. So essentially what we need to do is define the turning point, and the y coordinate of the turning point is going to be our maximum value of y. So to go through and do that, I'm going to rewrite this as y equals negative x squared plus 2x plus 8. I'll need to take a factor of negative 1 out of everything. So what I'm going to do is I'll go equals negative, nice big square bracket, x squared, and now the negative of positive 2x will be negative 2x. The negative of positive 8 will be negative 8. So then I take that part and I need to complete the square, or start to go through the process of completing the square at least anyway. X squared, take away 2x, and the x coefficient we divide by 2, so 2 divided by 2 is going to be 1, so plus 1 squared. Then we take away 1 squared again, and then we bring down our negative 8. This will be equal to negative x take away, and this is the one that we ended up with before. And to remind you where they came from, we basically take the x down from there, that sign goes to there, and it's this number which goes to there, and then the negative 1 squared is negative 1, and then take away 8. We'll simplify this again, so we have x minus 1 squared, take away 9. Now I need to get rid of those square brackets, so what I'll do is do that. So negative of x minus 1 squared, and then this will become plus 9 outside that bracket. And that tells us that our turning point will be at positive 1 and positive 9. So therefore y max will be equal to 9. That's the answer to that question. Next we have a multiple choice question for you to look at with credit to Evans, Lipson and Wallace, 2006. We're looking at a parabola and we're trying to work out which one of these equations is going to match. So if I was to look at this, I don't know what our shape coefficient is going to be, but it's going to have a general form of y is equal to a x minus 2 squared plus, sorry, not plus 5, because it's negative, it's take away 5. So that negative 5 comes from here, and when we go inside the bracket we do the opposite, so we get negative 2 in the bracket, which is positive 2 in the x direction. Now we don't know what the shape factor is, we can't actually work it out because we haven't been told any exact values for the y-intercept or for the x-intercepts. They're approximate figures but not exact figures. So I'm going to see if we can do a process of elimination with the equations that we have available to us. Now, the first two of those equations, we have y minus 5 or y plus 5 on the left hand side. So if I was to take this equation and shift the 5 to the other side, we would end up with y plus 5 is equal to a x minus 2 squared. So that can tell us that we'll rule out the first equation because it has y minus 5, so it can't be a. The other thing that I'm going to do is, if we have a look at the actual bracket that we've got, x minus 2, if there's any equations that don't have x minus 2, so this one is x plus 2, so it can't be c, and the last one is x plus 2, can't be e, and then if we look at d, it's x minus 5, so that's not x minus 2, it can't be that. So simply by a process of elimination, we end up with option B as being the correct answer.